This is Unit 5, Investigation 2, Lesson 3. We're going to be starting off with a simple addition problem of two fractions that have different denominators, and we're going to be doing some work today with adding and subtracting rational functions. So here, we are going to be starting off with 1/3 plus 2/5. Here, what I need to know is I need to know what my common denominator is. Okay, that's the most important thing you need to do whenever you're adding or subtracting fractions. So here, my least common multiple seems to be 15. So that means that I need to multiply 1/3 by 5 and 2/5 by 3. And here, notice that I'm multiplying both the numerator and the denominator. Whatever you do to the numerator, you must do to the denominator, and whatever you do to the denominator, you must do to the numerator. Okay, so whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. So here, I'm going to have a new expression. I'm going to have 5/15 plus 6/15, and now that I have a common denominator, I can add my numerator and simplify to one term. And 5 plus 6 is 11, so I'm going to get 11/15. Moving on to the concept development, we're going to be adding and subtracting rational expressions. So here we have 2x over x minus 1 plus 3 over x plus 5. Here we do not have a common denominator and we need one. So here, instead of multiplying by numbers, we're just going to be multiplying by expressions to have the same denominator. That way we can easily add the numerators and simplify all of our expressions. So here, since we do not have a common denominator here, I have to multiply 2x over x minus 1 by x plus 5, and I have to multiply 3 times over x plus 5 by x minus 1. So here, I've color-coded so you guys can follow my work. And here, if I multiply 2x by x plus 5, I'm going to get 2x squared plus 10x. And then over on the right here, if I multiply 3 by x minus 1, I'm going to end up with 3x minus 3. Notice that they're all over the same denominator. So on the left here, we have x minus 1 times x plus 5. And then on the right here, we have a denominator of x plus 5 times x minus 1. That is the same thing. Those are equivalent denominators. Does not matter what order you have them, because you're multiplying those two factors. And because order does not matter in multiplication, these are equivalent denominators. So we can actually keep it all over one denominator for the remainder of the problem. So here, all we need to do is we need to add our numerators. So here, if I add my numerators, all I'm doing is just adding my two numerators that I have listed above. And now, if I look at this numerator, I can see here that there is going to be some common terms that I can combine together. Okay, so I'm going to combine my like terms. I'm going to see that I have 3x and 10x here, and that can be combined to 13x. So here I'm going to simplify to 2x squared plus 13x minus 3, and again, you're going to keep it all over the same denominator, x minus 1 times x plus 5. And that is your simplified expression. Moving on to the next page, we're going to be practicing adding these rational expressions. We're going to be also placing restrictions on each denominator, because we know that in any rational number, rational expression, rational function, we cannot have 0 in the denominator or it will be undefined. So what we're going to do first is we're going to actually place those restrictions on each of these examples first. That way we can focus on the adding of our rational expressions. Letter A, we're going to start with letter A. We're going to set 8v cannot equal 0. And here, if you divide 8v and 0 both by 8, you're going to get v cannot equal 0. You could have also jumped to that conclusion, knowing that if you have 8 times v, if v is 0, that will create 0 in the denominator. Letter B, we have x plus 7 and x minus 8. Both denominators have to be set equal to 0. If we subtract 7 from both sides on our denominator, and then we add 8 to both sides on our denominator over here, we're going to end up with x cannot equal -7 and x cannot equal 8. Letter C is a little bit more complicated. We have two denominators, 3x plus 1 cannot equal 0 and x plus 5 cannot equal 0. If we have 3x plus 1, we actually have to do a two-step process to solve for that restriction. We have to subtract 1 from both sides and then divide by 3. So here you're going to see that I subtracted 1 from both sides. I got 3x cannot equal -1. And then when I divided by 3 on both sides, I got x cannot equal -1/3. So instead of a 1-step, it's a 2-step. Here we have x plus 5 cannot equal 0, and we just had to subtract 5 from both sides to get that x cannot equal -5. Lastly, we have letter D. We have x plus 3 and x minus 3. Both cannot equal 0. Note that 3 plus x and x plus 3 are the same thing, and either way we get x cannot equal -3 and x cannot equal 3. Lastly, for letter D, we have 8 plus n cannot equal 0 and 1 plus n cannot equal 0. Here we can just subtract 8 or 1 from both sides, and we get n cannot equal -8 and n cannot equal -1. Now that we've established our restrictions, we're going to be simplifying our expression. Letter A, we have u minus v over 8v plus 6u minus 3v over 8v. Notice that here we have the same denominator, so we can actually add both numerators together, and we're going to get u minus v plus 6u minus 3v. Here we have common terms that we can combine. So if we combine these like terms, we are going to get u and 6u, that is going to create 7u, and -v and -3v, which is going to create -4v. And we're going to have all of that all over 8v, and that is my simplified expression. Letter B, we have 3 over x plus 7, and we're going to be adding 4 over x minus 8 to it. We do not have a common denominator here, and in order to have a common denominator and add all of our numerators together, then what we have to do is we have to multiply this 3 over x plus 7 by x minus 8, and we have to multiply the 4 over x minus 8 by x plus 7. Again, whatever you do to one, you must do the other. So whatever you multiply the numerator, you must multiply that by the denominator, and vice versa. So here, if we have this multiplication, we have 3 times x minus 8 on the left and 4 times x plus 7 on the right. But we can have it all over one denominator, because that is the reason we are multiplying this way, so that way we can combine all of our terms in our numerator. So here, if I multiply 3 and x minus 8, I'm going to get 3x minus 24. And here, if I multiply 4 by x plus 7, I'm going to get 4x plus 28. So I have all of those terms all over the same denominator. And now I can combine my like terms, because all I'm doing right now is simplifying. So if I combine my like terms, I can combine 3x and 4x, and I can combine -24 and 28. So my simplified expression is going to be 7x plus 4 all over x minus 8 times x plus 7. Letter C is a little bit more complicated, it seems, but don't let yourself get tripped up. We have x over 3x plus 1, and then we have 2x squared minus 2 all over x minus 5 times 3x plus 1. So notice that both of these rational expressions have 3x plus 1 as a factor. So all I need to do is multiply the 3x plus 1 by x minus 5 on the left here, so that way I can have the same denominator, and because I'll have a common denominator, I can add all of my terms in my numerator. So here, if I multiply x minus 5 by 5, and I'm going to keep the 2x squared minus 2, because then I'm going to have the same denominator, and I can add both of my numerators. So here I have x times x is going to give me x squared. X times -5 is going to give me -5x. So here I'm going to have x squared minus 5x plus 2x squared minus 2. Here I can combine like terms, and I can see I can combine x squared and 2x squared, and I'm going to be left with 3x squared minus 5x minus 2 all over x minus 5 times 3x plus 1. Letter D, we have 9 minus 3x all over x plus 3 times x minus 3, and we're going to be adding 2x over 3 plus x. So I just want to note first that x plus 3 and 3 plus x are the same thing. So all we have to actually do is we have to in order to get the same denominator and add all of our numerators together, we need to multiply the expression on the right by x minus 3. So here, we're just going to multiply by x minus 3 on both the numerator and the denominator. And here, if I do that, I'm going to have 9 minus 3x. I keep that the same. And then I'm going to add whatever 2x times x minus 3 is, which is what we have from over here. So now all I need to do is distribute the 2x into the x minus 3. And if I do that, I'm going to have 2x times x will give me 2x squared, and 2x times negative 3 will give me negative 6x. So from here, now we're going to combine like terms all over again. We can combine 6x and negative 3x, and we're going to be left with 2x squared minus 9x plus 9, all over x plus 3 times x minus 3. Lastly, we have letter E, and here we have 8 plus n on the left, and we have 1 plus n on the right as denominators. So here already we know that we do not have a common denominator. In order to have a common denominator, we are going to have to multiply by 1 plus n on the left expression and by n plus 8 on the right expression. Again, whatever you do to the top, you must do to the bottom, and vice versa. So here I just have to show my multiplication, and I'm just going to add it all over the same denominator just so we don't have to keep rewriting everything. So we have whatever 2 times 1 plus n is, and we have to add 4 times whatever n plus 8 is. So that's what I have over here. And in order to simplify, I have to distribute 2 times. So I have to distribute the 2 and the 4. And if I do that, I have 2n plus 2, and then I have 4n plus 32. And we could just add those all together. It does not matter what order you add because of the associative property. So here I can combine my like terms. I can combine 2n and 4n, and I can combine 32 and 2. So my simplified expression is going to be 6n plus 34 all over n plus 1 times n plus 8. And here we have all of our simplified expressions.